JWTs are tokens that are mostly used for authentication and authorization in web-based applications. In this video, I'll walk you through detailed step-by-step guide on how to properly integrate JWTs with Spring Security to secure a Spring Boot application. We start off by giving you an overview of how the whole Spring Security framework works and how it secures the application under the hood. And next, we integrate JWTs into it by introducing a filter that would follow in the flow. And finally, we look at how to invalidate these JWT tokens with the use of Redis. And the cherry on top is that we'll also be generating refresh token to ensure that the access token have a short time to live, while the refresh token will be sent to the server to require a new access token. Welcome to IO Codes, and my name is Isaiah. And if you are coming across this channel for the first time, please do well to subscribe to this channel, ping that bell icon, and give the video a thumbs up just to help the YouTube algorithm. Now, without much further ado, let us jump right into it.
In order for you to have a jolly ride with me on this video tutorial, you should have Docker installed so you can pull the Redis container from the Docker hub, and you should also have Postman installed in order for you to test the different endpoints. And finally, you'll have to move on to the main repository of the project, which is right here, and I'll be providing a link to this repository in the video description. And right here, we want to simply clone the start branch. And the reason for cloning the start branch is just so you get a proper understanding of everything and you can code alongside with me while I am implementing mine. And secondly, you get to help the channel by increasing the watch time so I can get monetized as soon as possible. So to clone the start branch, you have to make use of this command. I've placed it right here in the readme of the main branch, and there is a little bit of difference between the main branch and what we are going to be implementing. I would say the main branch, or what we'll be implementing, is simply an optimal version of what we have here in the main branch. With all of this stated, we can get started with the whole development process of this project and see how we can use JWT and Spring Security to secure our Spring Boot application. If you followed all of the previous steps correctly, you should now have the start branch of the project inside of your personal computer. And just like me, you must have opened it up inside of your preferred IDE. And for me, that IDE happens to be IntelliJ. So let us quickly take a close look at the content of the start branch. So I'll collapse this. And right here, we have the .gradle directory. And this .gradle directory is included as a result of my project being a Gradle project. And after which we have the .idea directory, which happens to be an IDE specific directory that will be included to the project. So if you are to be making use of another IDE, take for instance Spring 2 Suite, you'll have a .sts directory included in the project. So we have the Gradle, the full Gradle directory, then we have the source directory, which includes all of the classes and the resource that will be defining for this particular project. I have our git ignore, and then we have the build.gradle, which is where we've defined all of the different dependencies that will be associated with this project. Let us go through these dependencies. We have Spring Security and Spring Web. These two denotes that we need Spring Security implementation for the application, and for the web indicates that we are building a web application. And the next happens to be Redis, and Redis will be used for storing all of the invalidated token because of the time it takes to read and write to Redis. I think it's a perfect fit for that job. And after which we have JPA, because we'll be making use of an SQL database, which happens to be H2 for the persistence of our users. And after which we have JWT specific dependencies. And right here we have the API, the Jackson, and implementation of this dependency. So if you are not following with the start branch, you can simply head over to the Maven repository at this endpoint. I'll be providing you a link to this in the description section of this video, where you can go ahead and add these three dependencies to your own project. So this is the implementation, the API, as well as the Jackson. These are the three dependencies that are needed. So back to our project, what we have next is Lombok. So this would be used for getters and setters as well as some constructors. And after which we have the test dependencies. We are not going to be running any test, but I just left it as is. You can go ahead and remove these test dependencies and the test directory from your project. It just depends on what you prefer. So with all of those stated, let us take a close look at what's contained inside of our source directory. So right here we have a couple of packages: the config package, the controller package, entity, as well as the service package. Now, starting with the config package, we are going to define all of the necessary configurations that will be needed for our application. I already have a template right here already. I've defined a security config package. Do not fully optimized at the moment. I mean, not fully optimal. We are still going to be adding a couple of configuration to this class, but then this is just the base. And the next is our controller. So this demo controller exposes just two endpoints: the /hello endpoint and the /customers endpoint. Let me make a quick correction to that. Okay, as it returns a customer entity. Okay, so that is that. Okay, now the next one happens to be our entity, which happens to be the customer. And in this scenario, it happens not to be a full-blown entity, as it is not being annotated with identity. I don't want to go ahead and start saving this in our database. I'll do that with the user that will try to get the list of customers from our application. And finally, we have a JWT service class, which is practically empty for now. I'm going to be providing its own implementation after I give you a brief overview of how the Spring Security workflow works. And just before we go ahead and do that, let us quickly take a close look at our resource directory. So we have a keys directory, private.pm and public.pm, that defines a couple of keys that we'll use to generate our own keys for authenticating and validating users, or perhaps for creating a JWT token. Pardon me for that. For creating and verifying. And finally, we have the properties file in YAML format, and I've defined the base for this. We have configurations for JPA and the data source. So right here we have an in-memory URL for our H2 database, and we have the driver defined. And because we are making use of H2 in-memory database, our DDL auto for Hibernate will simply define as create drop. So it implies that when we start off our application and end our application, all of the users that are being stored inside of the database should simply be deleted. I mean, the database automatically is deleted and all of its content will be deleted as well. So with all of those stated, let's quickly take a close look at the Spring Security workflow. When a client sends a request to the server responds back to the client with the requested resource. But at first, that request gets intercepted by what are known as filters. Now, these filters include the cause filter, the CSRF filter, and in the case whereby we have a Spring Boot application, whereby the Spring Security dependency has been added to the build project file, a new filter called the Authentication filter is added to the list of filters. Now, this authentication filter simply checks the security context to see if there is an already authenticated entity associated with the thread. And if there is an authenticated entity, it simply returns back the requested resources to the client as a response. However, if that is not the case, we have a 4.1 unauthorized or a 4.3 forbidden sent back to the client. Now, for the client to get authenticated, the client has to send in the desired or the required credentials. At first, the authentication filter simply delegates this to the authentication manager, which in turn delegates it to the authentication provider. The authentication provider in this scenario makes use of the user detail service to request or pull out the user from wherever it has been stored, might be a DB in our scenario, retrieves the user and makes use of the password encoder to encode the password that was sent alongside the authentication request. It validates that the user already exists inside of the application and simply makes use of the authentication manager to store this authenticated entity in the security context. And afterwards, the desired resource is being sent back as response to the client. However, if this authentication process is failed, then we have a scenario whereby a 401 unauthorized or a 403 forbidden is sent back to our client. And this is the whole picture of the Spring Security workflow. Now let's get back to our application. With that explanation, we now have a glimpse of how Spring Security works. And the major reason for Spring Security being implemented in an application is to prevent unauthorized access to the application by unknown entities. And the entity in question for this application will simply be the user entity. Now, Spring automatically already defines an interface that every entity or a user of the application should simply implement, and that interface is called the user details. So I'll go ahead first of all to create a user class, and I'll simply add to Git. We're going to implement this interface, which happens to be the user details interface, and this is coming from the Spring Security Core dependency, Spring Security Core package, as the case may be. Now, because of a kind of similarities between our customer class and our user class, I'd love to copy some of the fields, which happens to be the ID and the name. I'll move back to the user class. I'll paste this right here, and back to the customers class. I'll copy the whole of this, simply cut it out since I don't need it inside of this class. Moving back to the user class, I want to paste all of this import statement right here at the top. So now we want to annotate, perhaps copy the whole of this annotation as well. Control C and place it right here. We don't have to type it out ourselves. And right now we want to annotate our class with that entity. Okay. Next would simply be to annotate it again with at table. I want to give a name to this table. That should be underscore users. Okay, so I start right here. Because I have an entity, I'll have to provide the necessary strategy for the value of the ID of this entity to be generated. So we have a generation type of identity, and you can see that tab 9 is automatically giving me suggestion. I'm just simply tabbing it in. And finally, we want to change this field to username. So that is that for now. But then again, our user will need a list of rows. So I'll go ahead now and have a private feed of strings that happens to be a list, and this should be called rows. Okay, and I will have to import a list class from the UTs package. Now that we've implemented the user details interface, we'll have to define the method, or perhaps implement the method that is being defined in that interface, which happens to be the get authorities method. So I'll do an implement method, and we'll simply go ahead and click on OK. One of the method I want to take out is the get password method. I'll delete that part. And right here, I want to simply add that field, private string password. And right, you can see that that error is gone. The reason is because we already have a getter annotation coming from Lombok, and since we already have the username and the password field, it's already been implemented by Lombok itself. Okay, so we don't need to go ahead and implement those again. But for the granted authorities, the collection of granted authorities, we have to implement it. So I'm going to return this list, and this list simply goes like this. So it's, I'll simply go rows dot stream dot map. I'm gonna have a rule, my bad, simple granted authority new, and we're gonna collect this to list. Okay, can be to set as the case may be. So this is the list of authorities associated with this user. Now that we've defined our user, I want to go ahead and simply define a user repository for this entity. So this should be auth insert, and we want an interface. This should be user repository. And it extends the CRUD repository. We'll pass in user, and we'll pass in the type of the ID, which happens to be long. Finally, we are going to define just a single method which returns an optional user. I'll simply find the user not by the ID but by the username. I'll take out this override. We're going to have a string. I have username. Okay, and so that is all we need. And we also have to annotate our class with our repository so that a bin is created for us that will be managed throughout the life cycle of the application. So that is that for our user. From that workflow, we saw that not only the user plays the role in the whole Spring authentication context, we saw other major components such as the password encoder, the user data service, as well as the authentication provider. Now, for us to define all of those, we have to go ahead and create a new config class inside of our config package. And this class, will simply call it the application config, which I'll just give app config for short. Okay, I'll click on it. And to make this class a configuration in Spring, we'll have to simply annotate with at configuration. Okay, so we have that right here. So go ahead now and define the respective bin. I'll start off with that of the password encoder. So this should be at bin. We have a public, and we're going to have a password encoder. We have password encoder right here. We're going to return an instance of a new bcrypt password encoder. So this should be return new bcrypt password encoder, and we simply pass nothing as parameter to the constructor. Now this is for the password encoder. The next bin we want to define is the user data service bin. So the user data service is what is the user data service is what Spring used to load our user from wherever we've stored the user. So I'll go ahead now and create that bin. So I'm going to have at bin again public user details service. And before we go ahead and provide this implementation that bring our user or queries our user from the database, we want to quickly take a close look at the method that this particular interface defines. So this user details service interface defines just a single method, which happens to be the load user by username, and it returns an instance of user detail. Now our user class already implements this user details, so we'll go back to our app config to inject an instance of our user repository, which will be used to query our user from the database. So this should be private final. My bad, I'll have to skip from that. So this should be user repository. I want to have user repository. So to fix that, we have to annotate our class as well with our required ask constructor. So back to our user data service bin definition, we want to return an instance of this. So if I'm to go ahead and do something like this, return new user data service, we'll have to go ahead and provide implementation for this load user by username. And right here, I'll do something like return user repository dot find by username. We'll pass in the username. Okay, and because what it returns is an optional of user. If it's present, we simply get the user, or else we return a null value. But in this case, we want to throw an exception since this method already throws an exception by default. So we're going to do or else true. And at the end of the day, we want to end this with a semicolon. But the beauty of things is that we already have, we can make use of lambda expression in this scenario. So instead of having multiple lines, we can simply wrap all of this to a username, and then we simply have to return user repository dot find by username. We pass in the username and we'll do or else true. Okay, so that is that for the bean definition of our user details service. So moving back, we have to define a new bean which should be our authentication provider. So this should be public authentication. I'll have to type that in. We have provider. So right here, we are going to return an instance of a new authentication provider. So we are going to have DAO authentication provider, and it should be equal to new DAO authentication provider. And right inside of the constructor parameter, we're going to pass in an instance of our password encoder, which is bcrypt. And next, we want to set our user details service. So we set that. I'll just simply tab it all in since it's coming from tab 9 and it's exactly what I want. And finally, we return this authentication provider. Now, just like with the set user details service, we can also set the password encoder. So we have DAO dot set password encoder, but since we already passed it as parameter to the constructor code, there is no need for that. So that is that for our authentication provider. Now the next being in line is the authentication manager. So we'll go ahead now and have the bean definition again. We have public authentication manager. And one thing is that this particular function taking an instance of authentication configuration. So I'll scroll down, my bad. I'll scroll down all till where we have authentication configuration. I'll pass in the config instance, and right inside of it, we are going to return an instance of the manager from it. So this should be return config.get authentication manager. Okay, I'll end that with a semicolon. We have this error indication indicating that we have an unhandled exception, so we have to add the exception to the method signature. So I'll click on this to fix that. So here we have the 4 different beans that we will make use of. Let me take out this unneeded import statement. Okay, and right now we are perfectly fine to move on to the next stage. So far, we've majorly been concerned with the Spring security implementation side of things and paid little or no attention to the JWTs. Now we want to go ahead and implement our JWT service class. But before we do that, if you don't already have an idea on what JWTs are, you are coming across this for the first time, perhaps if you already have an idea, then this should just simply be like a refresh to your memory. So the best place we can get the whole concept and idea on what JWTs are and what they look like is from the official JWT website. So I'm going to pull up my browser, and you can see right here we have the page, and from this section we see that JSON Web Token is an open standard that defines a compact and self-contained way of securely transmitting information between parties in a JSON object. So we have when should you make use of a JSON Web Token for authorization and for information exchange. Now this should simply just be a walkthrough. I'll be providing a link to this page in the description section of this video, so you can go ahead and read through to have a proper understanding of what JSON Web Tokens are. Now the structure of the JSON Web Token consists of the header, the payload, and the signature. So it looks like x.y.z, and the header contains 2 parts: the type of the token which is JWT, you already know. And the signing algorithm that is being used can be H-SHA-256 or ROSA. Now in our scenario, we are going to be making use of ROSA. Okay, and now the payload contains a couple of things called the registered claim, or the public claim, as well as private claim. Let's go through it. The second part of the token is the payload, which contains the claims. Claims are statements about an entity and additional data. There are three types of claims: registered, public, and private claims. These are sets of predefined claims which are not mandatory but recommended to provide a set of useful interoperable claims. Some of them are issuer, expiration time, subject, and audience, and others. Now, public claims can be defined at will by those using JWTs just to avoid collisions. Okay, so that is for public claims. Now, private claims are custom claims created to share information between parties that agree on using them and are neither registered or public claims. So we have an example of the payload and how it looks. So we have the subject, the name, and an admin. And finally, the last part of the JWT token is the signature. So to create a signature part, you have to take the encoded header, the encoded payload, a secret, the algorithm specified in the header, and sign that. And for example, if you want to use this particular algorithm, HMAC SHA-256, the signature will be created in the following way. Okay, should be the algorithm, the base64 URL, encoded header, as well as the payload, and then a secret as well being passed in to the specific algorithm. So now finally we have a JWT token. If we put everything together, and it looks like this. This is the first part, and this the second part, and finally this is the third part that was earlier represented by x.y.z, as we saw from these parts right here. Now, to debug a JWT token, you can simply take any token of your choice and come over to this debug page to see the content of the claims. In this scenario, we have the header, we have the decoded payload, and we can see that this signature, or perhaps the secret, is valid. As you can see, we have valid secret and the signature. Now, our scenario, because we'll be making use of ROSA in place of HMAC, we want to generate an example. So we are going to select the signing algorithm, which should be ROS256. And right here, we have the token. You can see valid JWT and signature verified. Unlike the HMAC, where we just need a single key, which simply makes it symmetric. In the case of ROSA, it's asymmetric in the sense that we are going to have a public key and a private key. So the private key would be used to issue the token, and the public key would be used to validate the token. More on that when we get to the implementation of all of this. So right here we have the algorithm JWT, and we have the payload, and finally we have the valid public key. As you can see right here, it begins with this statement, begin public key. And you must have come across this in scenarios where you want to SSH probably into Git, or even working with AWS. Okay, so that is that. Now we can move back to the implementation of all of this right inside of our project. Right, back to our project. Before we go ahead and provide implementation for this JWT service class, we want to at first create our private and public keys. Now, to do that, I already included a commands file inside of the start branch, so we'll have to open that file, and we can see that we have an open SSL command here to generate an ROSA private key for us. And then we have another open SSL command to extract the public key out of the private key that was previously generated. So we'll simply go ahead now and open the terminal, copy the whole of this command at first with Ctrl C, and right here we want to switch to git bash. Okay, and I'll simply go ahead and paste in this command, and then I'll click on enter. Now we should have a private.pem file created. I'll copy the second command as well, and shift insert to paste, and then I'll simply click on enter again. I'll have the public perm key file in a couple of seconds right now, so give it some time. Okay, and here we have these two files. So I'll move back to my keys directory directly inside of my resource directory, and I want to delete the previous keys we had, which were just simply keys on a single straight line. So I'll highlight the both of these keys and I'll delete them, and I'll copy these new ones we've generated and simply place them right inside of our resource directory. Okay, so that is that. And now we want to define this part, the keys part, inside of our YAML file. So I'll go ahead now. We're going to have ROSA private key dot path. Right there, we're going to have a class path, have the keys, followed by the private .pem file. We'll repeat the same thing for the public, so I'll simply type that in, and I want to take out these parts, it's not needed. So that is that for validating codes from LLMs by these different agents. So we now have the two class, we now have the two keys defined inside of our YAML file, the paths to these two keys. But let us quickly take a close look at the keys that was generated. Now we can see that we have this first part, begin private key, just like we saw it in the JWT.io website when we previously viewed it. And for our application to practically work with this generated keys, we don't need the new lines, the extra lines generated, and we don't also need this part as well, and this part, both for the public and for the private key. So we have to create a component class or a utility class that will paste this for us as we want. So I'll simply go ahead now, and inside of the service class, I'll create a key generator service class. So I'll do an alt insert a Java class, and this should be called key generator service. Alt to git. Right here, I'll simply annotate this class with at component. Okay, it's my bad, not configuration, but at component. Now we already know the logic that this simple class is going to implement for us. So without us wasting much time on that logic, I'll simply go ahead and paste a snippet of the code right inside of our class. So I'll walk you through everything so you get a proper understanding of what is going on right here. So firstly, we have injected our key part, and we simply define type as resource because they are pretty much resources, the private key resource as well as the public key resource. However, in this scenario, what we want is something different. So this should be ROSA dot private dash key dot path. If I'm correct, let me quickly open up. Okay, yes, I'm correct. And then we move back to the class. I'll highlight the whole of this, Control C, and make necessary corrections to the next, and this should be public. Okay, so that is for the private key and the public key. I'll collapse this and this one as well. Now for the clean key, what we are simply doing is replacing the begin marker and the end marker. The end marker is simply the begin keyword we have here and the dashes associated with it, and the end keyword we have here and the dashes as well as the other words associated with it. So back to the key generator service class, we are replacing this with simple empty string, and after which I'll collapse this to a new line while replacing any extra line and tab with empty string as well. So that is for the clean key. It takes in a resource, the begin marker and the end marker, and it reads the part of that resource, reads the string inside of that resource after retrieving the URL, that is the path that leads to the string, and then we store it in the value of key string, after which we simply return the key string after replacing the begin marker and the end marker. Take note of that. Now that method we just defined, it's a private method. We are going to use it for generating our private key and for generating our public key. Alright, these two methods are similar in a way since they all go ahead, since they pretty much do something similar, which is the generation of keys. However, I want to point out something. That is one thing. When we make use of the clean key function we previously defined, right here we have the private key resource being passed as parameter, and then we have begin private key and begin public key. So these are pretty much differences between these two methods. One, and for the second one, we have different key specs that is used for the key generation. For the private key generation, we have the PKCS8 encode key spec, and for the public key we have X509 encode key spec. So we can't use the same key spec, otherwise during the validating or the verification of the token we are going to have an exception thrown in our application. So let's go over it. Firstly, it checks that our private key resource is not equal to null and that it also exists. If not, it throws an exception. After which we decode the the cloning key, which is the key string that will be returned after it is being carried, after it is being properly pasted by this function, and then we take that key, decode it, and get the byte. After which we take the key factory and get an instance of ROSA as the algorithm. Finally, we generate our private key and pass in our key spec while passing in the key byte that we've decoded. It is the same thing for our generate public key. However, what we are passing to our clean key function in this scenario is the public key resource and the begin public key, as well as the end public key. And finally, our key spec is pretty much different from that of the private key. So that is pretty much it. I'll love to make all of this pretty much readable, so I'll be making some edits right here. So from this part where we have the dot decode clean key, I'm going to put it in a new line, and here we have it. Okay, and the next thing is to repeat the same for our generate public key. So right here we have this as well. So that is that for our key generator service component or class, as you call it. I'll move back to our JWT service class. Our JWT service class is definitely going to make use of our key generator service. So at first, we are going to annotate our class with at required ask constructor. Let me make that be on its own line. And now we are going to have a private final key generator service key generator. Okay, I'll leave that as the name. And I want to define two feed variables, which will be private final long, and this should be called access token TTL equals to 5 multiplied by 60 multiplied by 1000. So this will automatically give our access token 5 minutes to live. Okay, so access token TTL simply stands for access token time to live. I'll repeat the same thing for our refresh token. So this should be I should just simply tap that in, and in this case we are having something different. So we have hour, we have 24, after which we are having 30 days. We don't want something like this, so we want to change this. So instead of 30 we are going to be having 7, and right here we have just 5 because we are going to be having only 5 minutes for our access token to live. And after our access token is invalidated or has expired, we can simply send a request to our refresh endpoint to get a new access token to allow the user access our application. With the TTL of the access token and the refresh token defined, we can go ahead now and generate our JWT token and the refresh token. So right here, because I want this function to, generate tokens both for the access and the refresh token, I'll have to change this name to simply generate token instead of generate access token. And in addition to the subject that will be passed, we are going to pass in another parameter called the token type. And I want to change the name of this subject to the username, which should be the username of the entity or the user that would be assigned this token. And right now we are going to pass in the second parameter, which is token type. Now, before any further implementation, we want to carry out the first check, and that is to check if this token type is the one we want to generate an access token or a refresh token for. So firstly, we're going to say if not token type dot equals access underscore token, and not token type dot equals refresh token. I'll type that in. What we simply want to do is to throw an illegal argument exception. So I'll simply type the whole of this in, and we are going to have a statement or an exception message that says token type not supported. That is first. Now, if it happens that this token type is of access token or of refresh token, then we can go ahead now and at first define the expiration time. So now to do that, we're going to have expiration time var expiration time should be equal to system.currentTimeRelease plus, now depending on the token type, so we're going to have a boolean a ternary or operation right here that takes in the token type, and if this token type equals a refresh token, then the value that should be added to the system current time release should be the refresh token TTL. Otherwise, we should have the access token TTL. Now, my bad, because what I implemented here is wrong, so we're going to have a question mark instead. So right now with this, we can define the expiration date. So right here, we're going to have expiration date. This should be equal to new date, and I'll type that in expiration time. I want to make proper correction to this spelling. I'll import the class as well. Okay, and then we end this with a semicolon. So right now we can simply generate and return the token. Firstly, we start off by returning JWTs.builder, and we have compact at the end of the day. And in between the builder and the compact is where we define all of the necessary claims. At first, I'll be starting with the header, and we want to define the type of the token. Now, don't mistake this type for the token type that we are trying to pass in as parameter, but this type is pretty much different. It's the JWT type. Okay, and right here I made a simple error. I'll have to correct that. So we should have this defined differently. So this should be token type dot equals refresh token, not doing a direct or a straight comparison. This is not JavaScript. I'll simply end this with a semicolon at first. And now to concatenate this header part with our payload, we make use of the AND function. And now we define the time it was issued, which should be the new date, okay, without any parameters. Next would be to set the expiration time. So we're going to pass in expiration date followed by the claim that we want to set. And this claim will still be called type. However, it will be presented in the payload and not in the header of our JWT token. So right here, we're going to pass in token type. And just before the issue date and the expiration time, we want to pass in the subject, which would be a user name. So these are what defines our JWT token. So we've gone ahead now to compact this token, but we are yet to sign this token with our private key. So to do that, we include a new function called before the compact function called, and that should be the sign with. And here we are going to have our key generator, and we are going to be signing with our private key. Take note of that. Now we've defined this, we want to go ahead now define a function that simply extracts the token. So to do that, we will have to move down to public claims. We're going to have extract claims, and here we're going to pass in the token. Right here, we are going to um, tap the whole of this in. So we have to paste with our set signing key, which is generator.generate public key, paste claims GWS, and get body. So the body is simply more like the payload. Now this is quite the old way of doing things, and this is where these LLMs come short of. And to do it the new way, firstly we are going to have a payser, not a payser builder. You see that in this scenario we now have all of this squiggly line indicating that this mode has been deprecated. So we're going to have verify with, okay, we're going to have build, and right here we are going to have paste signed claims. We pass in our token, and instead of getting the body, we want to get the payload. So that is that for extracting the claims. However, we want to simply extract, the subject or the expiration date. Now, all of these are what we use to check the validity of the token. Now, just to save our time from all of those implementation, I'm going to paste all of those logic right now into this class, and then we go through them. So right here, we firstly have the extract expiration, and so it extract the claims, and from the claims we can get the expiration, and then we extract the subject, which happens to be the username that we've set when we created the token. Then we're also extracting the token type. Extracting the token type has to do with extracting the claims, and then getting one of the claims, because the claims that will be returned will simply be more of a map object, and from that map object we are getting a type, necessarily not a map object. If we open up the claims, let's see what is defined inside of this class. Okay, so you can see that it extends the map interface. Okay, so yeah, it kind of returns a map at the end of the day. So back to our JWT service class. So one of the key of that map is type, which we've defined, and it's right inside of the payload which was returned, and it returns the token type right here. Okay, so take note of that. And finally, we simply validate the token by extracting the expiration time and checking if it is after the current date. If it happens to be before the current date, then this return value should be false. But if it is after, then it means that the token is still valid and not yet expired. That is one way. However, if a user is to log out and the token expiration date is still in the future, we will see how to invalidate the token using Redis. So that is that for the JWT service class. Now with all of this implemented now, we can move on to our user service class to implement what is necessary for the registration and for the login of a user. But before then, let's see what this one is really all about. Okay, it says feed can be converted to local variable, but I'm fine with defining it as a global variable for this class. So I'll open up the file tree to create the user service class inside of the service package. So we're going to have user service. And here we annotate this class with our service. Yeah, the first two methods that this class will define is the register method for registering a new user and the authentication method for authenticating a new user. What the register method simply returns is an instance of the newly registered user. So go ahead and do that. And for that, we have to define an instance of our user repository. So this should be private final user repository. And let's have the required Axe constructor included. Right here, we're going to define our first method, public user, then import that class. Okay, should be coming from our entity package. Now, this function receives as parameter an instance of register DTO that just simply defines the feed that is used for registering a user. So we have register DTO right here. We can simply return user repository dot save. We're going to pass in user. We have user equals to null for now. So moving to this part, we want to create this register DTO. So we'll have to create the class, and we'll create this class inside of a new package called DTO, which stands for data transfer object. So I'll click on OK. I'll have the package. I'll add this class to Git, and if I collapse this, we'll now have the class right inside of the register DTO. Now this class doesn't define any feed yet, so we're going to move down to our entity package, open up our user class, and we just need these two fields, which is the username and the password. So I'll copy these two fields, move back to the register DTO, and place it right here. In addition to this, we want the annotations, getters and setters, as well as the all Axe constructor and no Axe constructor. I will paste it right inside of our register DTO class. Moving back to our user service class, we'll simply create a new user from this register detail. So we are going to have user builder, user.builder.build, and in between these two functions, we want to define the fields starting with the username. So right here, we're going to have register dto.get username. For the password, we're going to have password like this. Now we need to encode our password before saving it inside the database. So we're going to have a private final password encoder. So this should be password encoder. Remember the password encoder we defined inside of our app configuration class, this bin right here. So this bin would be the bin that will be injected into our user service class. So right here, we're going to encode our password. So this should be password encoder.encode. I'll pass in our register dto.get password. Okay. Now, for us to successfully perhaps create this user, we have to pass in a list of rows. So this should be rows. I'm going to have list of. Okay. Simply pass in the string user. Okay. So this is the role of our user. Now with this, we've created our user, and we can simply go ahead and return whatsoever the user that this method would simply give back to us. So that the user repository.save method will return back this user that is being stored inside of the database. Now, I want to point something out. That's the fact that when you are dealing with creating objects like this, you are trying to create a new object from another different object. Take the register detail and the user as an example. You want to create a mapper class for that, or a mapper implementation. So runtime, it generates that for you. I don't want to do that in this video, but just so you know, that would be a much more efficient way of doing it. So right now we move on to the next function, which is the authenticating of a user. So we're going to have a public. Now what we want to return in the case of authenticating a user is not just the user alone, we are going to return the access token back to the protocol or the controller class that will simply call this method. So we are returning both the user details and the access token. So for that, we're going to have a map of string and object value pair, because in the first case we are returning an access token which is a string, and in the other scenario we are adding a user which would be an object. So we are going to see that implementation right now. So this should be authenticate, and it takes in a couple of parameters which includes the login DTO, which is login data transfer object, and the HTTP response. Oops, my bad, not HTTP response, but HTTP servlet response. So that should be right here. We have the response. Just like our register DTO, we'll have to create our class inside of the DTO package. Click on OK, add, and it's similar to the register DTO. So I'll copy this, paste it right here, and copy all of these annotations, paste it right here as well. So we now have the login detail. The reason I'm doing it this way, even if they both define the same fields, is because in real world applications, or if you were to go ahead and implement your own um, logic, you might include extra field in the register details such as the email, the date of birth, and so on and so forth. But just to make it minimalistic um, implementation, I've defined just these two fields for the register details. So take note of that. And back to our user service class, we want to go ahead now and authenticate this user. To authenticate our user, we have to use the instance of our user detail service to load it from wherever it has been stored. So we're going to have private final user details service. Okay, and right here we want to get the user first. So this should be user equal to user detail service dot load by username. We are going to have login detail dot get username. We end that with a semicolon. And this error indication is because we are returning a user details instance, and so we have to typecast to user, so that error is gone. Next, we want to check that this user is not null. So if user is not equals to null, then we can go ahead now and authenticate this particular user. So to do that, we have to make use of the authentication manager. So just like the user details service, we have to define that field as well. So this should be private final authentication manager. Okay, auto manager is what I call it. So right here, we would go ahead now and simply authenticate this user, passing our user. The credentials should be null, and the next thing should be our user.get authority. So right here, I'll have to wrap it inside of a new username password authentication object. So this should be new username password authentication token. Okay, that's correct. This way we are authenticating the user. So I'll have to collapse this just to give a much more wider view of the content. And next, if this process passed successfully, what next is to simply go ahead and generate a JWT token and our refresh token. So at first we're going to have a var access token, and this should be equal to our JWT service dot generate token. Here we pass in our login DTO dot get username followed by the type of the token. Take note of that, and this is the access token. So this should be access underscore token. We end up with a semicolon. Now for our JWT service, we also have to inject that. So I'll type this in. So we have JWT service right here. The next would be our refresh token. So I'll type that in as well again. Now that we have these two, we want a new map object. Okay, this is pretty much what we'll return. So we are going to return a map dot off. Okay, right here we have the access token. I'm going to pass in access token, and then we are going to have our user. Then we pass in the user as what we'll simply return. Okay, so that is that. And we are pretty much not making use of the refresh token right now. The reason is because we cannot directly pass the refresh token to the response entity from our controller endpoint. That is why we have this response object right here. So right now we're going to have a cookie object. So this should be cookie. I'll call this refresh token cookie. It should be new cookie dot insert. Let's have that imported, and we are going to pass in the value of this cookie, which should be our refresh token, and the name would be called refresh underscore token. We will separate this with a comma. And there are a couple of things we want to set for this cookie. So we're going to have to set the masked age. So this will be refresh token cookie dot set max age, and this is pretty much in int format, so we have to specify the seconds, which is the TTL of the token, which happens to be 7 days. So this should be 7 multiplied by 24 multiplied by 3600 multiplied by 1000. So this right here would give us a value. So what I pretty much want to do is define that value by moving to my JWT service class. And we've defined it right here before, so I'll simply highlight it, Control C, move back to our service class and paste it right here. So we are going to have set mask age as the refresh token TTL. And because this value is in long format, we want to change it to a type of int, and since it's a type of int, we'll take out this part that indicates it was in milliseconds before. So right now that error is fixed. And the next thing for us to do now is to set that this token should only be passed only for HTTP only. So this should be true. We have to set the path. So this should be refresh token dot set path, and we have the slash endpoint. And finally, what are we simply setting? We are adding our cookie to our response object. So you see, all of these are logic I love to put inside of a separate function or method. So I'll go ahead right here and define this method called the get refresh token cookie. So this should be a private method, and it returns a cookie object, and it's called the get refresh token cookie. Takes in two parameters. First of all is the HTTP servlet response object, so we're going to have the response, and the next should be our refresh token. And right here we'll simply move the whole of this, so I'll highlight everything, Control X, and paste it right here. Let's see, simply call get refresh token cookie response. Then we follow that by the refresh token itself. Okay, so that's it. I'm moving back. I'll take out this part. It's my bad. Control X, and we'll paste it right here. And we don't need the response for the get refresh token cookie. So I'll highlight, and then I'll simply delete it. So all we need is a string, our refresh token. So I'll quickly delete this, and here we have it right now. So finally, we are going to return this cookie. So this will be return refresh token cookie. So now with this, we've simply defined both our authentication and our authenticate logic, as well as our register user logic. And let's see, we have an error. You can see right here, and it's from this section. So instead of not having return any object outside of the if statement, we are going to have this return map dot off, and we simply just have an empty map being returned back to our controller class. Having defined the two functions, we want to create our controller class that will make use of this function, and that should be the auth controller. So I'll create this class, and just like our demo controller, it should be annotated with the address controller. Okay, and right here we want the at request mapping, and it's going to be to the path slash auth. And now we are going to annotate with at required ask constructor, so it injects our service class for us. So we'll have a private final user service. Okay, and let's have that class imported as well. Now the first thing we want to define our function for should be for the registration of a user. So we're going to have at post mapping, and after the slash auth endpoint, we want the slash register endpoint. And we have public, returns the response entity of user, and right here we're going to call this function register. Let me simply import our class, and we request the body of this REST request, and we are going to make use of the register DTO that we've previously defined. So this should be register DTO. And right here, we simply want to return response entity dot OK user service dot register, or passing our register DTO. So that is that for the registration. Now for the authentication, we are going to have another post request. But this post request would be to the slash login endpoint public, and we want to return a response entity, and the type would be defined, and we are going to have name of our function as authenticate. It takes in the request body of login DTO, followed by, my bad, I'll have to correct that. It takes in this, I'll have to import the class, then followed by our HTTP servlet response. So this should be response as well. So now we're going to get our auth details from the user service. So this should be var auth details. Remember, it contains both the user details as well as the authentication token. So we're going to have authenticate login DTO. Let's see what we have right here. Okay, and secondly, we have to pass in a response object. Now we first of all check if our auth details is empty. So if auth details dot is empty, we want to flag this, change the implementation. If it is not empty, then you simply want to carry out this operation. Firstly, we're going to return a response entity of not OK auth details, but we want a different response entity. So the body we have here would be the user. So this should be auth details dot get, and we pass in the key, which is user. And just before the body, we want to specify the header. So this should be header. I'll pass in the name of our header, which should be our authorization header. And here the value should be the string bearer, include a space, and then we add our auth details dot get. Here we pass in our access token. So that is it. Now put all of this in separate lines, starting with the header, and the body would be in its own line as well. So we are simply just passing in the access token from the map object that is returned from this, and then we're also setting the body to be the user entity that was gotten from our database. I'll type this in a bit. Okay, so right here you have all of this in one scene. Now that is that. Now in the case whereby the auth details happens to be empty, we want to return this a status of 401, and we can have invalid username and password as invalid username or password as the body of the request. Now we've defined all of this, both for registering a user and for logging into the application, and we've also defined our user service. But if we are to start our application right now, Spring Security will not automatically infer that we have a JWT service implementation in place. Remember from what we previously saw, we saw that when a request is sent, it's been intercepted by filters, and from that filter, there are other logic that comes into play. And JWT implementation was not one of it. So what we want to do now is to generate or perhaps define a custom filter that will include or integrate inside of our security filter chain, so that from there we can provide our own authentication logic. So to go ahead and do that, we are going to create a new package called insert. It's a Java class, but we are going to place it inside of this package called filter. So this should be JWT authentication filter, and click on it. Then we simply add to Git. Okay, right here we want this class to be a component, and it simply implements or perhaps extends the once per request filter class. Here we are going to provide implementation for the method that is defined, which is the do filter internal. So I'll click on OK for that, and we want to put all of this in a new line so we can pretty much view it in one go. And to ensure that all of this squiggly line is gone, like one we have to annotate with at null coming from Lombok. Copy this, move down, paste, repeat same here, paste again. So we have this defined, and we can go ahead now and start the implementation. First thing first is to simply get hold of our security context. So this should be security context. My bad. So we just simply go and get the context. But then again, once we equate this to security context, okay, I'll simply call it context is equal to the whole of this. Let's end that with a semicolon. And the next thing is to get our authorization token as well from the request header. I want to check that this token is not equal to null. But before that, we want to also carry out a different check. So if token equals null, or there is already an authentication object inside of our context, so which will be context.get authentication is not equal to null, so that we don't end up validating a user twice. Okay, I'll have to take out this comma I placed right here. Okay, if this is the case, we want to move on to the next filter in the chain. So this should be request, and we pass in the response, and finally we simply return filter chain dot do filter, and we just go ahead and return out of this function. However, if that is not the case, we want to simply extract our JWT token. So this should be string JWT token, and we should have the token dot substring And don't forget we have the bearer string from the beginning of the whole token coming from our request body. As you can see right here inside of the auth controller class, we prefix the whole string, that's the access token, with this bearer, so we have to extract it out at first. So moving on to our authentication filter, we want to begin from index 7. We'll store this as our JWT token. Next now is to simply extract the username from this token. So this should be string user name, and this would be equal to JWT service dot extract subject. And here we are going to pass in our JWT token. As a result of this, we'll have to include the at required ask constructor, and then we have to define our JWT service class, an instance of that class. So right here we have the username. I want to carry out some other checks. So we have to say if username is not equal null, that is one, and JWT service dot validate token, JWT token, as well as for JWT service dot extract token type, we pass in the token. I want to ensure that it equals access token. Now if all of these tests passes, then we can move on to the next implementation. So the reason for having this extra check is because if we take a close look at our token definition, we've defined it in a way that both the access token and the refresh token looks alike. However, the only difference is the extra claim that we included in the definition of the token, which specifies it as a refresh token or an access token. If this check happens not to be here, then it simply implies that even with the refresh token, we can access the application. Whereas the major functionality of the refresh token is to simply get a new access token from the application. So with this, we can load our user. So this should be user, and we'll have to typecast, as we'll be making use of our user details service dot load user by username, and we have to define an instance of this. Okay, so let's have that. So we have user details service instead, and let's take out this one. So now with this, we can get an auth token. So this should be our auth token to be equal to new username password authentication token, not filter, where we pass in the user, null as the credential, and finally our user authorities. Okay. The next thing is to simply set our authentication, so I said that move our request to the next filter chain. So we are going to have filter chain dot do filter request and response. I missed something, and that is directly before our setting of the authentication. So we are going to have auth token dot set details, and right here I want to pass in an instance of new web authentication details, and we'll pass in our request as parameter. So that is it for our filter class. I'm going to take out this import statement is unwanted, and here we've defined our user JWT authentication filter. I was mistaken for this. Now to ensure that this works as expected, we have to make them final, and I'll repeat the same thing for our user details service. So in case I've missed this in any part of the whole implementation of the project, please correct that on your own part. Moving to our user service I want to as well make this static so that this warning is gone, and we can repeat the same thing for the JWT service class. I'll look for that class. It's right here. So I'm gonna have static instead, and static. So that is that. Now by just defining all of this, we've pretty much done most of the job. Now to apply our filter, we have to do that inside of our security config class. So it's right here. We want to go ahead and inject this instance. So we have private JWT authentication filter. This should be JWT authentication filter. So we have to make this final as well. And we have to include the as required Ask constructor. So right here, we want to apply a couple of changes to this already defined implementation. So starting with the CORS, so we have cause. We're going to pass in the abstract HTTP configurer. Then we disable the settings for cause. We repeat the same thing for the CSRF. So I'll type that in. And here we have this right here. So after this function of authenticating all the requests, we want to apply our session management. So okay, I'll simply accept this, because at the end of the day, we have to add a JWT authentication filter before the username password authentication filter. And before that, we want to ensure that our session management is stateless. So we're going to pass in session. So right here we have session.session creation policy, and we have stateless. So just to make it much more concise and compact, I'm going to take out this part and let's just do a static import. Okay, so we have the stateless, and finally we want to set the authentication provider to the bin we've defined inside of our configuration class. So I'll go ahead now. In addition to this, we're going to have a private final authentication provider. So I'll type that in, and I have to import this class as well. And let's take this from picture, and we can push this backwards a little, push this in. Okay, so we've applied all of these. We can simply go ahead now, run our application and test it to see that it's working as expected, hopefully. So I'll go ahead now and click on this run icon to get the application started. Now our application is started and everything seems fine. However, I want to point out something, and that is the fact that we cannot go ahead and start registering a user or try authenticating a user. The reason is because the only part I've permitted is the /hello endpoint, which I was supposed to implement before starting off the application to ensure that we can register a new user as well as authenticate that user. However, because this endpoint is permitted and we have this endpoint inside of our demo controller right here, we can go ahead and call the endpoint and we'll get this. However, we can't call the /customers endpoint. So I already have Postman opened up, and I've defined pretty much all of the different requests we are going to be sending to our server, from register to authenticating of a user and to getting the data of a user. Now this theory is what we'll be majorly focused on at the moment. So moving on to the get data endpoint, we want to move to the /hello endpoint, and we'll send this request and we should get a response saying, "Hello, welcome to Spring Security Integration with JWT and Redis 2025." Now, right here, I'll change the endpoints to customers, which is a secure endpoint in the application, and we will be presented with a 403 for building. So we have to move back to our project and ensure that we make necessary corrections. So back to the security config class right here, we want to match this path to /auth/login. We're going to have /register, and that is the tool we want for now. Now, any other path for the application will simply be authenticated. So I'll go ahead now and restart our application. And moving back to Postman, we can register a user now. So I'll click on send, and hopefully we should get a 200 OK with the details of the user being sent back to us. And you can see we have the password in an encoded form. However, in real world applications, we don't want something like this. We want to hide the password and prevent it from being sent alongside the details of the user. So we're going to see how to do that in a jiffy. Now back to the authentication of a user, we'll simply send this request again, but now we are passing in just the username and the password. Now we have a 403 for bidding. Okay, so we have to fix that. Let's quickly take a close look at the exception that was thrown. So right here, it happens that no exception was thrown. However, let's see what we've defined wrongly. And here, have to do a little bit of debugging. Right now, after a century of debugging, I was able to figure out where my error was coming from, why the application wasn't working as expected. So right here, inside of the authenticate method in the service class, I was supposed to pass in the username and the password, and instead I did something we previously did inside of our JWT authentication filter, which was to pass in the user, the null, and the authorities of the user. However, in the case here we are trying to authenticate with the authentication manager, we won't do something like that. So what we have to do is pass in the password and the username. So this should be login dto.get username followed by login dto.get password. Okay, so that is it. I'll simply type that in, and it seems like we have an error. Let me collapse this and figure out what the issue is. So right now, yeah, we are good to go. Now take out this breakpoint, and I'll have to open up my demo controller. I think I have a couple of breakpoints there. So I'll simply go ahead, stop the application and run again. Now this time around, the application should work as we would expect. And over to my config class, that's the security config class. There's something I also made changes to. Okay, I'm yet to make changes to it. So for the /auth/register, though it works, I didn't include the /auth in the first place. It doesn't matter, but then again, just because I'm including it before that of the login, I love to include it before that of registering. So back to Postman, we're going to send a request again to our register endpoints to register this user. We are continuously doing this every time we start and every time we stop and start the application because we are making use of an in-memory database. So back to the authenticate user, we are going to send a request now, and we should have a 200 OK hopefully. Now we did get a 200 OK, and we still have the password being sent alongside the request. We have the list of authorities, and for the cookies we have the refresh token, and for the headers we've included the authorization token right here. You can see that the refresh token was automatically included as well. So I'm going to copy the whole of this bearer token. I have to copy it without the space, so let me do that properly. So this should be a right click and then copy. And moving on to our get data, we want to specify the authorization type, and it should be sorry, not basic auth, but bearer token. Right here we are going to paste that token. Now we can send the request to our endpoint to get the details of the customer. So this is the details of the customer, and we can also check the hello endpoint, and we should also get a response back from the server. Now take note that this endpoint now has been protected because I removed it from the list of permittable endpoints when I made that implementation of allowing our register user endpoint and our authenticate user endpoint to be accessible without authorization. So this is it. Now what next we want to go ahead and implement is the logout functionality and the getting of a token with our refresh token. So I'll move back to my application. Just like the register method defined and the authenticate method defined inside of this user service class, the logout method on its own is going to carry out its own logic. Firstly, it's going to invalidate the access token and then invalidate the refresh token, as well as deleting it from the response cookie or the request cookie. In order for us to achieve that, we have to ensure that Redis is up and running, and we have an implementation of it right inside of our application. Firstly, for us to do that, we want to move over to our configuration file. I want to post in some Redis specific configuration. So right here, it should be directly under the Spring block. So we have spring.redis.host localhost, and our port would be 6379. And recall that we are running Redis on a container, using a container, and it's being run using our Docker engine. And the commands to start up this Redis container goes like this. So we are going to have Docker run. We specify the name of the container. I'll simply call it Redis. We want to map the port, so this should be 6379 column 6379 again. Now the name of our container is simply Redis. So with this command, you are good to start up Redis, but ensure that the Docker engine is already running. So if you are making use of a Docker desktop on a Windows machine, you want to at first open the Docker desktop. If you don't have an idea on how to go about this, it's just simple. Just copy the whole of this and paste inside of a PowerShell terminal or Git bash terminal. Now I have a full Docker tutorial series on the channel, just released a couple of weeks back. You can go and check out that video just so you have a proper understanding of Docker. It's a nice start if you don't have any experience with Docker before now. So I'll close this and close this. And right inside of our user service class, we can simply go ahead now and inject a Redis template. But I want to kind of separate this implementation. So right inside of our service class, I'll create a new Java class which I'll call the Redis service class. Simply add to Git, and right now we want to annotate this class with that service, and we can also include the required Axe constructor. So the first thing we want to inject to this class is the Redis template. So we're going to have private final. We have a string Redis template, and I'll simply call this Redis template. And the first method we want to define is to check if the key is present inside of our Redis database. So we have our public boolean has a key, and the key in question will be the token that is being invalidated, or perhaps I'll simply call it has a token. And we have a string token. So we're going to return simply tap the whole of that thing. That is for checking if a token is already in the blacklisted DB, or if a token has already been blacklisted and stored inside of our Redis DB. The next one is for us to define the function that simply save this token to the DB. So I'll simply tab the whole of this in, it returns a void, and we have redis.ops for value, and we set the token and the value associated with the token. Now the value is would simply be a constant value for all the tokens. So we are mainly concerned with the key. So the key is unique across board. So with the token, we can make the token the key, and then we set the value. But now again, what we want to simply do is to have a scenario whereby the token inside of Redis has a specific time for it to live. And for us to achieve that, we have to go ahead and expand this particular function a bit. So we are going to have a long TTL, which stands for the time to live. You already know that. And then we specify the time unit this token will live. Okay, the reason for the time unit is for us to specify if it's going to be in seconds or in hours. So right here we are going to have the TTL followed by the unit of time. So that is that. Now we can inject this Redis service instance into our user service. So right under our JWT service, we're going to have a private final Redis service, Redis service. So let's define our logout method. So this should be public void logout, takes in the HTTP servlet request. We have a request, and there we will get the access token at first. So this should be string access token will be request dot get header authorization header. Okay, and now we want to simply invalidate this token. So we have invalidate token. We're passing our access token. So right now we don't have this function defined. So let's quickly create this function underneath. Okay. And the next thing for us to do now is to get the refresh token as well. So we can get the refresh token from the request cookie. So this should be string. I won't do string for now. So we should have cookie at first. Cookie refresh token cookie should be equal to request.get cookie dot filter, and here we want to pass in the cookie dot get name dot equals our string, which is the refresh token, and we want to find first. Okay, so that should be it. And let's see what we have here. Okay, it's an optional value, and to fix that we simply add the or else true. So it's very important that before accessing the logout endpoint, a user must be authenticated. So I want to place these ones in a new line so it's clear and visible for us all. So right now we are going to invalidate the refresh token from that cookie. So this should be invalidate, and we will have our refresh token cookie dot get our value. So that is that. And right now we want to update our refresh token cookie by setting the mass age to a value of 0. And just because we want to ensure that this is applied to the request that we send back to our client, we want the HTTP servlet response as well. So we're going to have the response, and right here we want to add that cookie. So we have response dot add cookie. Okay, so we have the refresh token cookie being added. Now for the invalidate access token, we are going to make use of the Redis service. So we have Redis service, and we want to simply set token. We pass in our token as a key. I'll simply call this token and not access token. Let's quickly update this. And after the token, we are going to pass in the value, which is blacklisted. And then we want to extract the time that the token will live. So right here, we are also going to make use of our JWT service class. So we have our expiration time, and this should be equal to JWT service dot extract expiration. We pass in the token, and then we want to get the time, and the time is in long, so we are going to divide this value by 1000. Okay, so this is the expiration time of the token. However, that is not the case for this time unit. The reason is because the expiration time would simply be a time in the future, and we want to ensure that before we do this division, we are subtracting it from the current time we have now. So to do that, we want to make use of subtracting the system dot current time millis. So I'll wrap the whole of this inside of parentheses, and then we simply divide by 1000 because I want to make use of the time units of seconds. So right here we are going to pass in our expiration time followed by the time units dot seconds. So that is it right here. And one thing I can simply do to make things a little bit more easy for me is to log out the expiration time. So we have log.info, and we can simply pass in the string expiration time in seconds equals expiration time. So with this, by just setting the token, we've pretty much invalidated the token. So we are doing it both for the access token as well as the refresh token. In that case, the values can no longer be used. That's the refresh token can no longer be used since it has been invalidated. But we are yet to provide the implementation to ensure that the refresh token cannot be used. Now for us to do that, we want to create another filter, which happens to be the token blacklist filter. So I'll go ahead, alt insert, and we'll create this Java class, which I'll call token blacklist filter. Enter, add it, and this class would be a component just like our JWT authentication filter. And right here, I'll paste in the content of this class. So it extends the once per request filter, as we can see right here. And let's see what we have here. Okay, everything is as it's supposed to be. And it's also inject a Redis service, and we can see that we are requesting for the authorization header. That's the authorization token from the request header, and checking that the token is not null, and the Redis service that has the token dot substring begin index 7. Take note of that. Okay, and yeah, I'll have to make correction to what I have inside of the user service. So I can't just go ahead and save and extract the token from, here's our logout. Okay, right inside of our logout function, what I simply did was invalidate the access token without firstly having a substring from where we have the bearer removed. So right here we should have dot substring, and we want to specify our begin index as 7. So this ensures that Redis is able to remove, our application is able to remove the space between the bearer and the token, as well as the bearer prefix, before using it as key for Redis. So now that we've done this, we move back to our token blacklist filter, and we are checking that the token is not present in our Redis database. And we can see that we have a couple of print line statements. If the token is present, we want to simply log out token has been blacklisted, and I'll take out this part. It's not needed. And then we simply send an error back to the user or the client. However, if the token is still active, we simply do a filter chain.filter or take out this log statement as well. Okay, so that is that. Now, for us to make use of this filter or properly implement this filter, just like with our JWT authentication filter, we have to configure it inside of our security config class. So right here, before the JWT filter, we are going to also add a filter before, and this filter would be token blacklist filter, and it should come before the logout filter. So we're going to have logout filter.class, and right here we want to ensure that we are defining an instance of this filter. Import that class, and here we have it. So I'll move back to my filter, and everything seems to be perfectly fine. Moving back to the user service, let's quickly take a close look at what we've defined right here. So we get the access token, and we also get the refresh token. Okay, and right here we set the mass age of this refresh token to 0, and we add this refresh token cookie to our new response. But after that, we simply validate the token. So I'd love to move this up before we set the mass age of our token to 0. So we are invalidating before adding the new details of the cookie to the response object. So that is that. Now we are here to make use of this logout method inside of our auth controller. So we'll go ahead now and define an endpoint for this. So we have at post mapping /log out, and now we want to simply say public response entity, and this should be of string, and we'll call this function log out. So right here we want the HTTP servlet request, and we'll type that in, and we are simply going to return this value, response entity.ok log out successful. Okay, I'll type that in. Now before we do just that, we want to make use of the user service. So this should be user service dot log out request and response. So that is that. Now return that. Remember that this is void, so it returns no value, so we can leave it as is. And right here we can simply return our response entity with the body logout successful. So that is that. Now we can test out this implementation before we define that of the refresh token endpoint. So before we get started with that, I'd love to open up the terminal and copy this command to ensure that my Redis instance is running. So I'll Control C, paste it right here, Shift Insert if you're on Windows, and I want to open up my Docker desktop so the engine starts running before I run the command. If I'm to go ahead and do it right now, you can see that it didn't work because the Docker engine has not started. So I'll have to wait a bit. So right here we have it starting the engine. So I'll move back to the application and I'll run the Spring Boot application. And while it's running, I want to open up the terminal again and run the Redis container. Okay, so now for you not to block your terminal when you run the command, you will do it this way, which should be a bit different. So you include the -d flag to run it in detached mode. So I'll click on enter, and I'll have to remove the previous one. So let's do it again. So this should be okay. So we have just the ID of the running container on Redis. So you include the detached flag to your command. So back to our run instance, we have started our Spring Boot application. So I'll open up Postman. And here we have to go through all of the requests again, starting with that of the register user. And so I'll send this request. And right here we have a cookie. We are not supposed to have a cookie from the register endpoint, but it's all good. So we move now to authenticate this user. So when I click on send, okay, we have the header. So we want to move to the header section and copy this new JWT token. So I highlight everything, Control C, move to our get data endpoint. I want to paste in this JWT token just like we've been doing it all along. So I'll paste it right here. But before we simply paste that, I want to simply undo it and send a request, and we'll have a forbidden response because this token has already been invalidated, probably expired because we've used it previously. Now we can make that change, so we paste in this new token, and now when we send this request, we have a 200. Okay. Now moving on to the logout part. Remember that we have to at first be authenticated before we can log out of the application. So I'll go ahead now and paste in this token and send. Now we have a 200. Okay. As for the cookies, it was sent back as well, and it's going to expire in 7 days time. So that's the implementation of taking out the cookies from the application. Didn't really work as expected. So let me take a close look at what we have here. We still have the refresh cookie. So let me close it. And I think I missed something, and that has to do with specifying the path associated with the new token or the new updates on the refresh token. So we are going to specify the path right here. So this should be dot path, dot set path, and it should be slash. And now I'll simply restart the application. Then let's open up Postman again. And while the application is starting right now, I want to highlight the whole of this token, Control C. And we're going to open up our browser. We want to head over to the JWT.io website to debug this JWT token. So right now we'll move on to debug part, and we simply highlight everything and paste it right here. Okay, so we can see that we've gotten the type, which is JWT, that we've previously defined. We have the algorithm RS256, and we can see it's a valid JWT, and it says fix public key input before errors to verify signature. Okay, our payload is as expected. We have the isaiah.iocodeaux.com, the time it was created, the time it will expire, and the type of the token, which happens to be access token. Now, just to give you a proper understanding, if I'm to copy this refresh token, Control A, I will highlight everything, each right here. So I'll simply copy this token and move back to the JWT endpoint and paste it, and here we have the type as the refresh token. Now to verify that this token is the real token and we have the public keys to it, we want to copy the whole of this public key, Control A, Control C, and move back to the website and paste this public key right here, and you can see we have a valid public key. So everything concerning the generation of the key is perfectly fine and okay. So moving back to Postman, we are going to send the request starting from the registration of a user again. So we'll send this request. Okay, and we got the body, which is the newly registered user. And to authenticate, we will also send in a request. And now we simply copy this token, move to the get data and paste in this token, Control A, V. I missed the letter, which is the letter G. So I'm going to copy it now, Control C again. So when I move on to make the next request, I'll get what is expected. So we get back details. Now, to that of the logout endpoint, I'm going to paste in the token again because this token has already been used and has been invalidated. So I'll paste in this token this time around and then I'll send this request. So we have a 200 OK, and right here we still have a refresh token, but we can see that the expiration time has now been set to 1st of January 1970, and we also specify the path. So if I'm to click on cookies right here, we'll see that we don't have any cookie. So it implies that a simple path I have missed to set in that refresh token was pretty much the reason why we had that kind of error. Now with this, we can simply go ahead now and exec into our running container. So I'll do a docker exec, and this should be in iterative format. So we have Redis, and this should be /bin/sh. Okay, it says unable to start container process. So let's do it from the Docker engine itself. So I'll click on this, open this part, and we run this command Redis CLI. We want to get in the list of keys in our Redis database. Now, if you take a proper look now, we have 3 different keys inside of our Redis database. So this implies that the implementations we've implemented so far is perfectly fine and working as expected. So with that, we can move on to defining an endpoint that takes our refresh token and creates a new access token for our client. So move back to our application now, but we have to stop our running container. And right here, we are going to implement that. Now, inside of our user service class, we can define the logic for requesting for a new refresh token. So this should be a public, and we should have a string, and we should simply have refresh token. It returns a string, and what we need right here is the request object and the response object. So we are going to have HTTP servlet request, and we use the request, then we follow that with the HTTP servlet response. The reason for having the request and the response is that at first we are going to request the cookie from the header, and then we get the value of the cookie from the request header. And for the response, we have to write a new refresh token cookie, and then we can then return the refresh, perhaps the access token, as a string back, which will then define inside of our controller that returns the response. So right here, we want to at first pull in the refresh token cookie. So this should be refresh token cookie. We already have something defined for getting that refresh token cookie. Let's see, we have it right here. So I'll simply highlight the whole of this, Control C, and paste that value here. The next thing for us to do now is to get the refresh token value. So we are going to have another variable defined. So this should be current refresh token, and this should be equal to the value associated with that refresh token. So we should just simply have the get value called. So that is that. I want to check our Redis template to ensure that this token does not already exist inside of the Redis database. So we make use of the template. So we have this Redis service.has token. We pass in this current refresh token as parameter, and we simply return a value of null, okay, which will ensure that we check. And the next thing, if it happens that this token is not inside of Redis at yet, I mean the current refresh token, we want to simply validate the refresh token. So we should have current refresh token, not refresh token, and we simply invalidate it. So we check if current refresh token is not equal null and it is valid, we make use of the JWT service validate token to ensure that it has not expired. We pass in the current refresh token. And we can carry out the necessary steps, which include retrieving the username or the subject from the token. So we should have username equals to JWT dot extract subject. Pass in our current refresh token. We end that with a semicolon. Next thing, we create a new JWT token with this username. So we're going to have our string JWT token, and this should be equal to JWT dot generate token, the username, and we pass in the type of the token, which is the access underscore token. And I will go ahead now and create a new refresh token. So this should be a string again. Pardon me, I'm making use of string and var interchangeably. You perhaps you already understand that, but it would be a good practice if I can keep all of them as var or string, as the case may be. I mean, defining the specific type. Here we are going to have a cookie. Here we're going to have a string. Here we have a string as well. So just so you know, it's type inference, by the way. But then again, just for the sake of good practice, I'll make use of var, since I already made use of var for defining right here. And you can see there's inconsistency sometimes, but then again, just take note of that. So back to right here, we are going to create a new refresh token, which I'll simply call new refresh token, and this should be equal to JWT service. But generate token again, we pass in the username as a subject, followed by the token type, which happens to be refresh underscore token. We end up with a semicolon again. Now that we've gotten this token, we want to set the response. So at firstly, we are going to define a new cookie. So we should have a cookie, new refresh token cookie, and this should be equal to, we make use of our generate cookie function, get refresh token cookie, and we'll pass in the new refresh token as the parameter. Okay, now we simply add this cookie to our response. So this should be response dot add cookie, and we'll pass in our new refresh token cookie. Okay, so that's that. And now that we've added this, we can simply go ahead now and return our JWT token. And finally, just to ensure that the error is not present, we go ahead and return null right here. So we're going to make use of this refresh token now inside of our controller class. So I love to collapse my source directory to the main Java and our auth controller. Collapse this. And I'll define our endpoint, which should be post endpoint, and it should be to the slash refresh path. Here we are going to have a public, and a response entity is not yet known, so we simply call this refresh token, and here we're going to have a request object at first, followed by our servlet response. The first thing first is to retrieve our token from our user service. So we're going to have var token and is equal to user service dot get dot refresh token, pardon me, and here we pass in our request followed by the response. Okay, that's for the token. Now simply highlight the whole of this. Let me get that, Control C, and simply paste it right here. Now in this case, we want to check that the token is not null. The token is not null definitely. So go ahead and check token is not equal to null, because that is either we return the token or the value. And if the token is not null, we can simply return a response entity of OK. We set the authorization header, and finally we go ahead and build these details. We end up with a semicolon. But then again, our authorization header is good to go, and here we are not returning a map, so we need to specify the value of the token. So Instead of that, we replace it with a token and simply return the build. However, if the token happens to be null, it implies that the refresh token might not be present or it's not a valid user. We are going to return something else, which would be an error. So we should have return response entity dot bad request, and we simply build this request. Then I think we can pass in statements right here. Let's see. No, should have a body, and we pass in invalid refresh token, or say refresh token not present. So you can go ahead and make use of any sentence or statement of your choice, but let me just leave it as is. And now I'll take out that build from the response body. So now we have this. What we want to do now is to simply head over to our um, application config file. So right here, move to the security config. We want to include that refresh path to the list of paths that is permittable. We'll use our comma, and we're going to have slash auth slash refresh. So now with this, I'll start the application and we can go ahead and test the implementation again. So hopefully I have my Redis instance running. Yes. Let's see, starting up right now. Now it's up and running. So I'm going to head over to the testing application, which is Postman. I'm going to go ahead and send all of the requests over again. So I'll send to authenticate this user, to create the user at first. Send. And we got a request, so we go ahead now and authenticate our user. So I'll send again. And we're going to get the data, just show you the workflow and the process. And it's going to fail because I haven't copied that token. So let's go ahead to the headers and get the token. Control C, back to get data. Paste in this token and we send the request to the server. Here's what's gotten. Now we want to at first request for a new access token. Now take note that we have the cookie right here in the path. Okay. And one thing I want to quickly point out is that now I have an access token, and when we request for a new token using the refresh token, we don't retrieve the access token. And in that case, now that I have another access token, it's still active, but I can go ahead and request for a new refresh for a new access token. So we now have two access tokens. So depending on your implementation, you can as well store every token that was associated with a refresh token, and immediately that refresh token is used, you can invalidate that access token to ensure that you don't have a scenario whereby we have two access tokens. Take note of that. But I'm not doing any of those implementation in this video tutorial. You can go ahead and go the extra mile, work on it, and see how you can properly secure your application to avoid such a scenario, especially if you want one user per session for your application. So right now, I can move over to no auth, and I'll simply send a request to the server and we'll get back a new token. Okay, so let's take a close look at what we have here. So we have this new token, and we also have a new refresh token. Okay, and it expires on the 15th of April, which is 7 days as from when I'm recording this video. So if I'm to move back to the cookie we have right here, let's see if they are the same. If I'm to open it up, let's see. Okay, now it has been properly updated. I think so. This ended with EQ. So you can close this and take a close look at what we have here. It also ends with EQ. So that is it. And right now, if I'm to go ahead now and log out with this token, Control C, I'll move back to the logout endpoint and paste in this token. Let's take out this new line that was added. And now I send this request. Okay, logout successful. If I'm to go ahead now and request for a new token using the refresh endpoint, you see that we have a situation whereby we won't get a token back because the token already now is inside of our Redis database. So just to check that out, we want to open up Redis inside of Docker and we want to simply run the command Redis CLI. We have keys. So now we have a token. I think we have that one with the EQ at the ending. So that is that for invalidating both the refresh token and the access token during the logout scenario. And for also validating a refresh token to ensure that the refresh token is still valid or hasn't been used once before we request for a new access token using it. So now we've come to the end of this video tutorial, and I believe you can now go ahead and properly secure your Spring Boot application while integrating JWT and also integrating Redis to properly validate the tokens. If you found this video helpful, please do subscribe to this channel, ping that bell icon, and also give this video a thumbs up just to help the YouTube algorithm. And until the next one, keep being your best self. I remain IU Codes. Peace out.